Example 1b, we'll go through that same process again if it helps to see it, solving by graphing. So again, I have my system of equations here, and this bracket just kind of helps show me, hey, we're looking at these two equations together. It's a system. We need to start off, if we're going to graph, by getting each equation in slope-intercept form, y equals mx plus b. And actually in both of these equations, we're pretty darn close. Let's get y by itself here. And the only thing I have to do to get y by itself is to move this 2x over to the other side. So that gives me y equals negative 2x plus 4. My other equation down here, x minus y equals 2. Again, we need to get y by itself. So since this is a negative y, I'm actually going to add y to the other side. X equals 2 plus y, and then subtract 2. Y equals x minus 2. At this point, both of my equations are in slope-intercept form. These are both going to be pretty easy for me to graph. And we'll go to our graph paper now. Example 1b, sorry. Our first line, let's graph the red since I have the red pen in my hand. Y equals x minus 2. My y-intercept is negative 2. Start there. And then my slope, man, what is that number in front of the x? Remember, if there's not a number there, it's really 1. My slope is 1, up 1 over 1, up 1 over 1. And then connect your dots. Y equals negative 2x plus 4. Same process, our y-intercept is that 4. Find 4 on your y-axis, and then our slope is negative 2. So from here we go down 2 and over 1, down 2 over 1, a few times until we can connect the dots. And it's a good idea to have more than 2. We could make a line with just 2 points, but having more than 2 dots on here is going to help us make sure that we are consistent with how we have our ruler angled. Looking at our graph, our 2 lines definitely intersect. At this point right here, 2, 0, that is our solution. In between example A and example B, it's a total coincidence that both have an x-coordinate of 2 for our solution.